Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over section 2.2a of our Algebra 1 virtual text. We're going to be looking at how to solve one-step inequalities. Before we get started, we're going to take a look at a real quick review on the four inequality symbols that we are going to be taking a look at in the problems today, and also a very important step to keep in mind when solving one-step inequalities. Alright, so let's go ahead and review our four inequality symbols. So the four inequality symbols that we're going to be looking at are as follows. The first one is the less than inequality symbol. Alright, so this is less than. And an example of the less than inequality symbol is x is less than a. For example, this is how it's written. You say x is less than a. And if you want to graph this on a number line, let's say this is a right here. Less than basically goes in the left direction and greater than goes to the right. Now, since there is no equal component in this inequality, that means that you have an open circle and less than goes to the left. Okay? Now, an easy way to remember the orientation of the less than inequality symbol is take a look at the letter L in less than. If you rotate this vertical part to the right or clockwise a little bit, it basically becomes like your less than inequality symbol. So L closely matches the less than inequality symbol, so L for less than. Alright, so that's just an easy way to remember to distinguish between less than and greater than. Okay? Alright, the next inequality symbol we're going to look at is greater than. So this is greater than. So if we have, let's say we have x is greater than some number a, if we want to graph it, if we have a on the number line, greater than will be open circle to the right. So any number to the right of that number a, excluding the number a itself, is going to be greater than a. Okay? Number 3, we then have less than or equal to. This is a combined inequality. Less than, or equal. Now, what is the difference between less than and less than or equal? So let's say you have the inequality x is less than or equal to some number a. The graphical representation will help us to clearly see the difference. So let's say you have a number a on the number line. Let's redo that. Move that to the left a little bit more. So let's say you have the letter a on the number line. Less than, we know, goes to the left, okay, just as indicated in inequality 1. Now, what is this equality component in the less than? How is that reflected graphically? That equal means that you close the circle, that the boundary point is included in the solution region. Alright, so if x is less than or equal to a, it could be a or anything less than. For x is less than a is anything less than a excluding a. Alright, so this line is basically an inclusion notation that includes the number that you're taking a look at. Okay? Alright, let's take a look at the last inequality, greater than or equal to. Okay, so greater than or equal. Alright, so let's take a look at an example used. So if you have x is greater than or equal to a, it's similar to the greater than, but the difference is that the a value is also included. So greater than is open circle going to the right. Remember, greater is to the right and less is to the left. Since we have this line underneath, it means that you close the circle. Okay, so these are the four inequality symbols that we're going to be looking at when we are solving the one-step inequalities in this presentation. Okay, and then one important thing to note, anytime you're solving inequality symbols, you must keep this point in mind. Note, whenever you multiply or divide by negative, guess what happens? You have to flip the inequality symbol. Okay, flip the inequality symbol. We're going to take a look at some problems where this rule is applicable. Alright, so don't forget this very important point. Alright, so let's take a look at some examples. What we're to do, instructions are for us to solve and graph each inequality. So for question 1, what if we have the inequality x minus 9 is greater than negative 4? Okay, so let's go ahead and solve that and graph. The solution is as follows. So starting with the original problem, x minus 9 is greater than negative 4. We can solve this inequality, or in other words, isolate x in one step. Do you see what the one step is? You simply add 9 to both sides. Why are we adding 9? We want to undo this minus 9. The opposite of minus is addition. So when you have minus 9, you do the inverse operation, which is to add 9 to both sides of the equation. And then what will that give us? That will give us these two add up to 0. And then we have x is greater than negative 4 plus 9. Subtract and keep the sign of the bigger, so x is greater than 5. Okay, so that's the answer for question number 1. Now let's go ahead and graph it on a number line. So how do we graph x is greater than 5? So we just graph a 5 on the number line. Remember, greater is to the right, less is to the left. So is this going to be an open or closed circle? Well, since there's no line underneath this inequality, is going to be an open circle, which means 5 is excluded. So any number that's bigger than 5 will satisfy this inequality here. Alright, let's take a look at another example. Let's say we have negative 1 is less than or equal to negative 8 plus v. So I want to solve this equation. This is another one-step equation. Do you see the one step that can help us solve this equation? The one step that will result in the isolation of v, or get v by itself. To accomplish that, we need negative 8 gone. So minus 8 can be moved over or can be eliminated by using its inverse. So the inverse of addition, of subtraction is addition. So you add 8 to both sides of the equation. Okay, so if you do that, if you notice what happens on the right side of the equation, what happens is that minus 8 plus 8 add up to 0. Okay, and then minus 1 plus 8, you subtract 7, keep the sign of the bigger, positive, as less than or equal to, this is 0v. Alright, so in order for us to graph it, we want to place the variable on the left side of the equation, so we're just going to make a switch. Okay, so we'll place v to the left, 7 to the right. So since 7 is less than v, what does that tell us about v? If 7 is less than v, that tells us that v has to be greater than or equal to 7. So if 7 is less than or equal to v, v is greater than or equal to 7. So when you switch the order of an inequality, you also have to switch the inequality symbol. Alright, so 7 to the right, v to the left, less than becomes greater. And this is the final answer. Let's go ahead and graph that on a number line. So here we're looking at 7. Greater than means you go to the right. equal means you have to shade in the circle. Okay, 7 is included in the solution region for inequality in question number 2. Alright, let's try another example. Question 3. Let's say we have the inequality negative 42 is less than negative 6k. Let's say we have this inequality. So we want to solve this. So we have negative 42 is less than negative 6k. In order to solve this inequality, we need to get k isolated. To get k isolated, this negative 6 has to be removed from the right side. Now, how do we undo negative 6 relationship with k? To undo that, we need to know what the existing relationship is and use the inverse operation. Negative 6k means that we have a multiplication operation. Alright, when you have a coefficient, the implied operation is multiplication. Now, what is the inverse of multiplication? The inverse of multiplication is division, so we're going to divide both sides of the equation by negative 6. And if you look on the right side, since your inverse is, you get the identity for multiplication and division, which is 1. So this goes here once, and this goes here once. And then what happens on the right side, on the left side? On the left side, remember, whenever you divide or multiply the same sign, you always end up with positive. So 42 over 6 is 7. Or you can just slash and dash. 7 is less than k. Alright. Now what happens if we put the variable on the right side? If 7 is less than, something to keep in mind, we divide it by a negative number, right? So if we divide by a negative number, what do we want to do? What change do we want to apply to the inequality symbol? Remember, we talked about this earlier. Let's take a look at it again. We said that whenever you multiply or divide by negative, flip the inequality symbol. Alright, that's something you want to keep in mind. So do we apply that rule here? The answer is yes. Notice we divided by a negative number. So this less than switches to what? Greater than. So 7 is greater than k. Alright? Now if we rewrite this inequality in the reverse order, we switch it around. If 7 is greater than k, that means k has to be less than 7. Okay, the inequality number symbol is pointing to k, whichever order that you write it in. Alright? So that, ladies and gentlemen, is the answer to question number 3. Let's go ahead and see what the graph looks like. K is less than 7. So we have 7 on the number line. Less than goes to the left. Now, is it a closed or open circle? Since there's no line underneath, it's going to be an open circle. And this is the graph of the solution. Alright, let's take a look at one more example. Question number 4. Now, what if we have the inequality p over 4 is greater than negative 2? How do we solve this one right here? Alright, so p over 4 is greater than negative 2. To solve this, we need to get rid of this 4 in the denominator. Okay? So p is being divided by 4. To undo that, we have to use the inverse of divide by 4. The inverse of division is multiplication. So we're going to multiply both sides by 4. Alright, so what happens? On the right side, these two undo each other. So 4 goes into 4 once and 4 goes into 4 once. So on the left side, we've accomplished our goal of isolating p, and that is greater than negative 2 times 4 is negative 8. Now, do we switch the inequality here? The answer is no. Why? Because we multiplied by a positive number. Had we multiplied by a negative number, like negative 4 for instance, then we will have to switch the inequality symbol to the reverse order. Now let's go ahead and graph the inequality. P is greater than negative 8. So let's say you have negative 8 on your number line. Um, Greater than goes to the right. So is this open or closed? Since there's no line on the bottom, this is going to be an open circle. And this, ladies and gentlemen, is a graph of the solution in question 4. Now, how well did you get the contents that we just presented? In order to demonstrate mastery, we would like you to try out the following problems. Okay, so when you copy down the problems, just pause the video and try out the problems, and when you're done, click on the play button to see what the answer is. Alright, so the instructions are the same. Solve and graph the given inequalities. These are just going to be one-step inequalities. Okay, we'll do 2 steps in the next tutorial installment. So number 1, what if you have x minus 4 is greater than negative 6? Number 2, what if you have 1 plus p is less than negative 6? Number 3, what if you have 10 is greater than or equal to 10n? Number 4, let's say we have for 4, b over 13 is greater than or equal to negative 20. Number 5, what if we have negative 2x is less than or equal to 10? And then number 6, let's say we have 10 is less than or equal to x minus 3. Alright, go ahead and pause the video and try out these problems. We are going to be displaying the answers momentarily. Alright, that's all the time we have. Let's go ahead and take a look at what the answers to the problems are. For question number 1, your solution is going to be x is, so for this one you're adding 4 to both sides. X is greater than negative 2. And then if you want to graph that, you have negative 2, open circle, pointing to the right. Number 2, for this one, you have p is less than negative 7. And then to graph this, you have negative 7 on the number line. You have an open circle here. Less than goes to the left. For number 3, we have n is less than or equal to 1. And then for this one, if you have 1 on your number line, you have a closed circle. Less than, you're going to be going to the left. Alright, let's take a look at problem 4. So for problem 4, your solution is going to be b is greater than or equal to negative 260. So if you have 260 on the number line, actually negative 260 on the number line, is going to be greater than, you're going to the right, and then since it's equal to, you shade in your circle. Negative 2x less than or equal to 10, the final answer will be x is greater than or equal to negative 5. And then if you want to graph that on the number line, you have negative 5. You have a closed circle because of the equality component of the inequality. And then since you're greater than, you will be going to the right. And then lastly, the solution to this is x is greater than or equal to 13. And then to graph this, just graph 13 on your number line. And then you have a closed circle greater than points to the right direction. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of inequalities, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other great algebra tutorials such as this. If you have any questions, comments, or requests, just place it in the comment section below and we'll be more than glad to assist. More videos, worksheets, games, and tools can be found at our website, mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.